metals we have the non-carbon content, that is the content of carbon will not be there in the non-ferrous materials. The example for them are the aluminium, copper, zinc and titanium. And the alloys are the bronze, brass, gunmetal and the bell metal. All these are the combination of the base metals only at the different proportions. All these will be mixed together to give a reliable mechanical properties. Okay, so we have studied up to here. Now let me go through the application also we have completed. Let me go through very interesting topic called the polymers. Polymers. So before that, we'll try to allow others who have entered. Polymers. So the polymers are the plastics. They are subdivided into three important categories: thermoplastic, thermosets and the elastomers. Please remember, the plastics are classified into three types: thermoplastic, thermosets and the elastomers. And why these names have been given, you can see them. Actually they are having a long chain molecules, okay, and they are very sensitive to the temperature change, and they melt well below the metals temperature. That means the metals will be melting around 650-700 degrees centigrade. Well within this they can be melted, and they have taken very good shape in the engineering family because of at low temperature they can be melted and they can be shaped into required shapes. Okay, required shapes. And so many problems have been solved by using these, and these have been replaced so many metallic components also. Okay, and now let us come to the thermoplastics. If I took the example of thermoplastics, you can look into this. Please remember, the thermoplastics are those can be melted many times. 100 times we can melt them. Many times we can melt them and we can reshape them to the required shapes. Thermoplastics, they can be melted many times and we can reshape them, and once they have broken or once they have been scrapped up, and those can be again converted into different shapes by adding some of the coloring agents. As you have seen here, you can see them. And some of the plastics which you can see them, they will be brittle in nature, and if you melt them, what happens? You are going to set them to a required shape. Once again it is not possible to melt, and we cannot shape them up once again. Okay, anyone have the doubt? Elastomers and elastoplastics. Elastomers and the elastoplastics. Elastoplastics are those can be melted many times. Many times we can melt them and we can reshape them to the required shapes by putting in the die cavity, or we can extrude them, or we can put them in the presses and press to the required shapes. But the thermosets, as the name indicates, once they have set down a required shape, it is not possible to melt them, remelt, and once again we cannot get into required shapes. Okay, those will be scrapped up. That is only the difference between the thermoplastics and the thermosets. Thermoplastics, you can see them, they are very economic, okay, and they are very highly viscous in nature. At low temperature they can be melted up, and many times we can melt them and their properties will not be changed. That is one of the important properties of thermoplastic polymers or thermoplastics, TP. Thermosetting polymers, as the name indicates, thermosets, once they have shut down, they have recrystallized, they have solidified, it is not possible to remold them once again. Okay, I think it is not required to understand the chemical reaction, how the chemical composition, all these are not required for us to understand. Okay, please try to understand this much only. And at elevated temperature, once again, if you want to heat them also, they will produce the metal. It is infusable solid they will be producing. The plastic will become hardened, okay, once after solidified, and it will give a mild crack on the surface. So it is not possible to melt them and get them to the required shapes. Okay, that is only the difference. And here I have shown many examples. You can get into the examples, you can see them. Okay, you can see the examples. The example for the thermoplastics and thermosets. Okay, thermosets, once they are shut down, it is not possible to use them once again. They will be scrapped. Okay, now let me come to the elastomers. Elastomers are even the super elastic materials also available. Those are not in the scope of our study. The metals, they can be just like rubber, we can stretch them without breaking. Just like even hair structure, 0.5 mm also we can make around this one and we can extrude them without breaking. Those are called the super elastic materials. They have their own advantage, and these metals have been recently found. I am not talking about them. I am talking about the elastomers. Elastomers, they exhibit highly elastic stability. That means even they can be stretched to a factor of 10. They can be stretched to a factor of 10, and once you leave them, they will be regaining their original shape and size. Elastic in nature. Elasticity is the property of the material. Once you have loaded, they will be changing their shape. Once you unload them, they will be regaining their original shape and size. Those are the properties of the elastomers. Okay, those are the elastomers. And the molecular structure and all, I am restricting here. I am not going to talk about the molecular structures. Okay, and what are the general properties of the polymers? Polymers are the plastics. Please remember, polymers are the plastics. These plastics are classified into three types: thermosetting, thermoplastics, and elastomers. Thermoplastics and elastomers and the thermosetting, all these polymers, they will be having the low melting temperature as compared to the metals. They are non-metallic. They are non-metallic. Okay, non-metallic, non-ferrous, and ferrous. There is a lot of difference. Metals have the ferrous and non-ferrous, and they are non-metallic in nature. Okay, and they have low melting temperature. They can be melted to a required shade. They can melt down, and we can liquefy them at low temperature, and we can put into cavity or you can extrude them. First important thing, the please look here, thermoplastics, thermoplastic. That means we can plastically change their properties by adding the temperature. Many times we can heat them, we can get into required shapes easily. So that I told you just now, many of the engineering components like the car bodies and some of the utensils, those are working at low temperature. All these, even the plastic bottles, you can see them. Grade of the plastic also will be written at the underneath of the bottles. You can see if you have the bottle with you. So either it is a thermosetting or thermoplastic, it will be given to you. So if it is a thermoplastic, then it can be recycled. If it is a thermosetting, it cannot be recycled, because once it has shut down, it will not be changing. It cannot be reused once again. Okay, and the third one is the elastomer. Elastomer is the one which will be exhibiting very extensive elastic properties, even 1:10 a factor of. That means if its length is the 100 mm, we can even increase up to 1 meter length without breaking. Once you leave it, it will regain its original shape and size. Those are the properties exhibited by these elastomers. Okay, and the examples of these thermoplastics are polyethylene, polyvinyl chloride, and polypropylene, and polystyrene, and nylon are some of the example for the thermoplastics. Thermosettings are phenolics and epoxies. Epoxy you have seen, I think, certain polysets. Okay, polyesters and all these are the thermosets. And elastomers are the natural rubbers. Those are vulcanized rubbers and synthetic rubbers which exceeds the tonnage of natural rubber. Okay, and you can see them, all these elastomers have the very good elastic properties. And now I am not going to take the general consideration of thermosetting or thermoplastic or the elastomers. Just general properties I am talking about. They have the low density as relatively as compared to the metals and the ceramics, and they have very good strength to weight ratio for certain polymers, and they are highly corrosion resistance. They cannot be corroded. Okay, now in the recent technology, the metal strip will be embedded within this plastic, and they are making it more stiffer. That is other technology. It will be called as a composite rubber. That weight is out of our scope. I am not talking about it. Okay, and they are low electrical and thermal conductivity. Their property, they are not good thermal conductors, and they are not transferring the temperature. That means they are not good conductor of the heat. Okay, and whereon we can limit them their usage, and they can be limited as compared to the metals and the ceramics. They have the low rate, low strength. Okay, and the modulus of elasticity is very less as compared to the metals. Modulus of elasticity, once you come back to the college, I'll be showing you one tensile testing machine is there at the department. We can see them. We can find out the Young's modulus or elastic modulus of elasticity of any material. We can subject it to no load and find out the change in the dimensions, the cross-sectional area and length, and we can able to note down the load applied, the change in length and original length, and we can able to find out the elastic property. Young's modulus E can be obtained. Okay, and now the Young's modulus of these the polymers are very less as compared to the metals and the ceramics. Okay, and their services will be restricted at elevated temperatures. Okay, only they can able to tolerate only few hundred degrees centigrades. Okay, and they cannot be used at elevated temperatures, and they are not having very good the load bearing capacity, since their capacity, the Young's modulus is very less, and they have the viscoelastic property. Where they will be viscous in nature, and they will be showing the elastic property also. Okay, and some polymers, they will be degraded. That means they will be dissolved at the sun temperature itself. They will be very sensitive to the radiation and the sunlight also. So these are some of the limitations wherein such conditions like the elevated temperature and the subject to various loading conditions and subjected to the various the sunlight and other radiation